Alright, and we are officially live. Yeah, today's the 4th. Perfect. For some reason, I thought I had the date wrong. Yeah, welcome on in, everyone, to this live. Tonight, we are going to be talking about trig derivatives. So, as you're coming on in, go ahead and hit that heart button. Let's see if we can't get to 1,000 likes before we get started. And while you're doing that, I will go ahead and work on the chat for a little bit, wave at everyone who I can, or click the button for everyone that I can. But if I can't see you, I will go ahead and, or not that I can't see you, but if I can't click a button to wave at you, I'll wave at you right now. Hi, everyone. So yeah, this is where we are. Hopefully everyone's enjoying their Thursday evening. I was actually just watching the Eagles-Cowboys game, but it went into a weather delay due to thunder and lightning in the area. But the game should be back on right now. I think last time I checked, the Eagles were up by 4 with about 3 minutes or so left in the third quarter. So yeah. Also, I also am playing. I have Saquon Barkley on my fantasy team playing tonight, so glad he was able to score a touchdown for me. But hopefully he continues to do that. Yeah, as I said, I'm gonna go ahead and click on as many say hi buttons as I can. Welcome on in, everyone. As you are joining in, be sure to hit that like button. Thank you, Chris, for the follow. And thank you, Brandon Z, for the follow. For the liking. Yeah, let's see if we can't hit a K likes before we get started. So, what else was I going to say? Oh, so I think to save us a little bit of time tonight, what I'll do is I will go ahead and give you the trig derivatives, and then we will do some problems involving those trig derivatives. And then for those of you who want me to do the proofs, I will do them in a separate video. In that video, you will be able to find... Where did my little note cards go? There they are. You'll be able to find that video right over here. So this is my channel over here. So if you go here and find this channel, that is my channel. So you'll be able to find me I'm going to prove all 6 trig derivatives in a separate video here. Just to save us a little bit of time tonight. Yes, welcome on in, everyone. Thank you so very much for all of your likes. So with that, let's go ahead. Now that we are at a K, let's go ahead and get started with tonight's live. So tonight, as I said, we're going to be talking about trig derivatives. So what are the trig derivatives that I'm going to be talking about? Well, they're going to be the 6 trig derivatives. I'm not going to get into the inverse trig tonight. That's going to be for another live. I think I'm going to be doing that live sometime next week. So, with that, let's go ahead and start with our trig limits. So, or trig derivatives, not limits. So, our 6 trig functions of interest. Thank you, Star, for the follow. So our 6 trig limits are going to be sine, cosine, tangent, and then we have cosecant, secant, and cotangent. Remember, the reason why I have 3 on one side and 3 on the other side, is remember that these three trig functions are reciprocals of these three. Sine matches up to cosecant, cosine matches up to secant, and tangent matches to cotangent. So let's go ahead and start by telling you what the 6 derivatives are. So suppose f of x is equal to sine of x. Thank you, Zombie Cat, for the follow. So its derivative, so I'll write the derivatives on the right. So f of x is sine, f prime of x is going to be cosine. That's right, MP. That is absolutely right. Very good. And then if f of x is cosine of x, I needed this refresher. I just started Calculus 2. Awesome. Welcome on in. Is there any way to prove it, though? Absolutely. And I'm going to do those proofs on a different video just to save us a little bit of time tonight. And you'll be able to find that video here. I might even do a short for all 6. I haven't decided yet. Thank you, Arthur, for the follow. The derivative of sine is not cosecant. That's right. You're absolutely right. I agree with you 100%. It's not cosecant. It is negative sine of x. What unit in Calc BC is this considered to be? This is unit, I think it's unit 2 or 3. Right. X squared is greater than 2x. That's not always true. Consider when x is 1, Rigo. 1 squared is not greater than 2 times 1. So, now, we're going to move into tangent. Its derivative is a little tricky. I'm saying the derivative of x squared is 2x, right? Yep, that's right. Hey, Math Tutor, how's it going? Welcome on in. Brand Z says secant squared. Hayden says secant squared. Thank you, Jenny, for the follow. Carter says secant squared. Yep, that's right. So its derivative is going to be secant squared of x. Thank you, Karen, for sharing the live. So, now, let's go secant next. Just because I can. So, if f of x is equal to secant, then its derivative is going to be, well, secant has a special rule where it's included in its own derivative. So part of it is secant squared. But right, Brand, it also is going to be multiplied by tan of x. Are we supposed to always memorize these or always know how to derive them? So usually we can use limit definition and the other derivative rules to prove these. But like I said, for the sake of time, and because sometimes I go page upon page with proofs, I'm going to go ahead and give you these tonight, and then in another video, I will go ahead and prove each of these. But yes, you will need to memorize these. Or if you don't memorize these, know how to prove that they're prove the derivatives. What's prime in this context? Prime. So a prime means the derivative. You guys, I can never remember how to prove them, and I took calc years ago. That's okay, Varen. So, like I said, in a different video, I'll go ahead and prove all of these. And like I said, I might even make them all shorts. I don't know yet. Thank you, Cone, for the follow. So now, we have two more trig functions to go. The derivative of cosecant is going to be, just like secant, it's gonna appear in its own derivative, negative cosecant, and then instead of tangent, it's going to be cotangent of x. And finally, if f of x is equal to cotangent of x, the derivative is going to be f prime is cosecant squared right, negative cosecant squared right. And those are your 6 trig derivatives. So, there we go. Now it's more in focus. Can I go over a quotient rule? I actually just went over quotient rule, I want to say last night. But, again, all of my lives are going to end up over here. Once I download them. And I'm actually, as I'm recording this, I'm in the process of downloading one as we speak. Thank you, Just Praise, for the follow. What's the derivative of e to the x? So, right, exactly. Very good. So, what are we going to do with this tonight? Well, tonight, we're going to do a few examples of taking derivatives involving our trig functions. And a good rule of thumb that I like to tell my students is that if it begins with a c, its derivative is negative. So, cosine begins with a c, its derivative is negative sine. Cosecant begins with a c, its derivative is negative cosecant cotangent. And then cotangent begins with a c, so its derivative is negative cosecant squared. Thank you, the math tutor, for the heart me. So, now, let's go ahead and do some exercises with this. So we're going to do a few different things tonight. We're going to do some derivatives where we are just adding or subtracting functions. We're going to do some power rule, and we're also going to do some quotient rule involving these trig derivatives tonight. Thank you, Panfer, for sharing the live. So I'm going to keep those up there. For now, actually, what I can do, I'm going to add them to my list of rules. So as you can see, there's not enough room for me to write these. So I'm going to go ahead and take a new note card and write these. I need to memorize these trig integrals would be so much easier. If you want, go ahead and take a photo. Go ahead and take a screenshot of it. By all means, if you want to take a screenshot of any of the work that I do, by all means, please do so. Thank you, Electrical, for the follow. Let me know when you are ready to... I'll give you a moment to take that screenshot. While you do that, I'm going to go ahead and get the first problem ready. Thank you, Richard, for the follow. So let's start with this as our first example of the evening. So here, I have x squared minus secant x plus 1. So remember what Rule 3 says for derivatives. Rule 3 says if I am taking the sum or difference of two or more functions, I can just, its derivative is going to be just each function's derivative individually and then added or subtracted together. And like that, this is true for any number of functions. If I had a 27 um, function here, or 27 term function here, I could just take the derivative of each of the 27 terms. Thank you, Dean, for sharing the live. Thank you, Isabella, for the follow. So f prime of x is going to be what? Well, here for x squared, I can use power rule. And remember what power rule says. It says if I have a variable raised to a power, its derivative, I can simply take the exponent, move it out front, and subtract 1 from the new exponent, from that exponent. So I have 2 goes out front, so that would be 2. X to the 2 minus 1 power, which is just 1. Remember that a variable without an exponent is the same as that variable raised to the first power. Is this Calc 1? I just learned derivatives in class today, but we find, yes, absolutely, this is Calc 1. Like I said, I'm not going to prove these 6. I'm going to prove them in a different video. Thank you, Math Tutor, for 5 roses. I apologize if I for just seeing those. But yeah, thank you. Derivatives clockwise on your xy axis, integrals go counterclockwise. Good to know. So now, I want to take the derivative of negative secant. So, I'm going to bring down my minus sign for now. And I want to know the derivative of secant of x. What's the derivative of secant x? Do I do Calc 2 problems? I do. In fact, I have a whole list of topics that I need to get to as soon as I get to Calc 2. Right, Brand. It's going to be secant times tan. So that's going to be minus secant x times tan x. And finally, I have the derivative of 1. Well, 1 is a constant. And if we look here, if f of x is equal to a constant, f prime of x is going to be 0. So the derivative of 1 is just simply 0. That's right, Brand. So because it's going to be 0, I'm not going to bother to write plus 0 or minus 0, because doing that is the same as this. So this is our answer. That is our derivative. Not bad, right? I don't think it's that bad. I believe integration by parts is already on my list of things to cover eventually. So tonight, I'm just going to focus on the derivatives of the 6 trig functions. Why did you add the tangent? So I assume you're talking about this tangent? Yes, that's exactly right, Grace. You're exactly right. The reason this tan joins in the party is because the derivative of secant is secant times tangent. Yeah. Okay, even though that secant in the function is negative technically. Yep. So all this does, so with the secant, tangent, and sine functions, whatever sine is originally in the function follows into the derivative. Whereas with cosine, cosecant, and cotangent, the sign would flip. But yeah, no problem. And like I said, I will make a video proving all 6 of these derivatives. But like I said, for time and for space, because if I do a proof of all 6 of these, I'm going to end up going through about 4 pages. So, thank you, Salt, for the follow. So now, let's go ahead and try another one. Like I said, tonight I'm just going to focus on the 6 trig functions and their derivatives. Thank you, Ado, for the follow. I apologize if I pronounced that incorrectly, though. So, let's try another one. Thank you, Liam, for the follow. So what you mean by constant, like, does it have to be 1 or can it be 2 or like 26? Nope, this is true for any constant. So any number without a variable, the derivative would be 0, whether it's 1, 2, 26, or 7,582. No matter what number you give me without a variable, its derivative will always be 0. Nope, because I'm not doing integration. If you do quotient rule on 1 over cosine, even pi, that's right. It could be pi, it could be negative, it could be the square root of 2. No matter what constant you give me, the derivative will always be 0. Correct, Grace. Again, I'm not doing integration, so the plus c is not necessary. And the thing is, once you know your derivative rules, for those of you taking calculus 2, when you can go from your from your derivative back to your original function. So it's really good to memorize your derivative rules because it'll serve you later when you have to do it in reverse. Yeah, but like that, it's a different process entirely to go backwards. It's like how multiplication and division are opposites. Taking the derivative and doing something called taking the antiderivative are opposites. Although most functions you can take derivatives of, some functions you can't take the integral. Right, Brand. But again, that's why it's really important to make sure that you got your derivative rules down. But yeah, Taylor series is already on my list. So now let's try another one. Let's do f of x is equal to 5 sine x minus 3 cosine x. Thank you, Better, for the follow. Thank you, Aiden, for sharing the live. So I want to find the derivative of that function. So here, I have a constant multiplier of a function. So if we look at rule 2, if I have a constant times a function, its derivative is going to be that constant times the derivative of the function. So let's see what we got here. So 5 times sine of x. Well, 5 is a constant, so that'll come along for the ride. The derivative of sine is what? Well, the derivative of sine, if we look across, it's cosine. So I have 5 times cosine of x. And then I'm going to bring along the negative 3. Derivative of cosine, looking up here, derivative of cosine, what's its derivative? Its derivative is negative sine. So this is going to be negative sine. So a negative times a negative gives me positive. So I'm going to flip that to positive and make that sine of x. And that's it. That is really it. And that's all. Let's try another one, but this time I would like you to give it a try. So, let's say I have f of x is equal to, what should I do? Let's do -7 tangent of x plus 4 let's do cosecant of x minus 3x squared. Thank you, Aaron, for the follow. Thank you, Itzel, for sharing the live. So now, go ahead and give that a try. What would be the derivative of this function? And also, let me move it a little way so that way it's more centered. Everything you need is on the screen. Go ahead and give it a try. Brinzy says -7 secant squared of x minus 4 cosecant cotangent x, or cosecant x cotangent x minus 6x with a question mark. All right. Do we agree? What chapter would this be under? So this is in Unit 2 of the AP Calculus AB curriculum. Derivative, take it away from high school and do like Calc 3. Eventually I'll be doing Calc 3. Right now I want to make sure that everyone has a understanding of the basics. Thank you for the calc refresher. No problem, Mr. Bermudez. Can you explain it, please? Sure. So, you don't miss it? Fair enough. But, so let's go ahead and look and see what we have. So, on the left, I have my trig intervals, my trig functions, and on the right, I have their respective derivatives. So, all 6 of these match up to 6 that are right across from it. Do you know when this is covered in IB math? I want to say it's later on in Math Analysis 1. Thank you, Riza, for the follow. How often do you go live? Right now, I only go live once a day. I'm working on starting a second live, but um, that is going to be a I want to make sure my current tutoring students are settled into their schedules before I consider a second one. All right, here, kitty kitty. As you can see, my cat has decided to join us, so I will be right back in a moment. Here, kitty kitty. Here, kitty kitty kitty. Here, kitty kitty kitty. Here, kitty. Here, kitty kitty. Here, kitty kitty. Here, kitty kitty. Come on. Here, kitty kitty. Here, kitty kitty. Come on. Here, kitty kitty. Here, kitty kitty. Here, kitty kitty. Here, look, look. Here, kitty. Here, kitty kitty. Come on. Here, kitty kitty. Look, got something for you. Come on. Here, kitty kitty. Here, kitty kitty. Good boy. Sorry about that. Yes, my cat my cat decides a lot of things. Thank you, Raisa, for the follow. But that's how you know I'm not pre-recording this or anything, because if I were, my cat wouldn't have jumped up onto the desk. Got it. Find the derivative of the kitty. Yes, and derivative of the cat is indeed kitty. But actually, there's a second derivative of cat. It's called fur. Because anytime the cat is around, the fur is sure to follow. Is this pre-calc stuff or calc? This is calculus. I still have a PDF on my calculus book, and I opened it up to parametric equations. Cool. We're gonna get to those relatively soon, but not like within the next couple weeks. So let's go ahead and finish this problem. So here, what is the derivative of negative 7 times tangent x? Well, the negative 7 is going to follow along. The derivative of tan x, if we look across, is going to be secant squared. So this is going to be negative 7 times the secant squared of x. Thank you, user, for sharing the live. And then the derivative of so 4 is going to join along. Derivative of cosecant, if we look here, derivative of cosecant is negative cosecant x times cotangent x. So this is going to be minus that. And then the derivative of negative 3x, take the 2, move it out front and multiply it by a 3. So that's going to be minus 6. X to 2 minus 1. 2 minus 1 is 1. Remember that a variable without an exponent is the same as that variable raised to the first. So we are done. I told myself to master this off memory and eyesight because I couldn't do it following steps. Okay. And hey, if that works for you, then go with it. There were trig rules, but these are derivatives. Yes. Of course, he picks derivatives that don't follow chain rules in respective operators. So tomorrow, we're going to be doing chain rule. Is this all you will be covering tonight? And do you go live at night, or does it depend on the day? So I try to go live every day at 11:30 p.m. Eastern. Right, so chain rule is like that. I'm doing chain rule tomorrow. So rather than do that. But I am going to do some with product rule and some with quotient rule tonight because we've already gone over those. Is this Calc 1 or Calc 2? This is Calc 1. But so as far as answering the question of is this all I will be covering tonight? So if you're talking about the trig derivative problems, yes. But I'm going to be doing different things with trig, so stay tuned. So let's go ahead and continue on to the next problem. But before we do, there are 22 of us in here. Let's see if we can't mad tap to 4K likes. Let's see if we can't do that quick mad tap to 4K. Taught my class chain rule yesterday and today. Cool. In your next live, will you be doing inverse of trig derivatives? Nope, I'm doing chain rule for my next live. Inverse trig is coming soon, though. I think that's going to be early next week. So tonight I'm doing trig derivatives. Tomorrow I'm doing I think I said I'm doing chain rule. Saturday I'm going to be doing implicit differentiation. And I think Sunday I have to take a look at where I am. Either it's natural log and E or inverse trig. I know I'm doing those two next to start next week. I just forgot what order I'm doing them in. Oh, we're perfect. Oh, we're already at 4K. Let's go. Awesome. So now, let's try a couple involving product rule. Thank you, Fields and Physics, for the follow. So, here, I'm going to let f of x equal, thank you, Hayes, for the follow. I'm going to let this equal x squared times cotangent of x. And I want to find the derivative of this function. I wish I got into TikTok when I was in school. I could have started a page like this. Now I don't know anything. That's not true, Land. You know a lot of stuff, I'm sure. And to be honest, I only just joined TikTok, I think, a few months ago. And I haven't been in school in about 15 years. Well, high school, that is. College was 10 years ago. Got a test in math next week. Hopefully, I'm sure you will, Dillbot. I have faith that you will do well on your test tomorrow. I mean, test next week. Yeah, tomorrow. Good job, Robert. Great job. What's the full question say for the latest example? So we're asked, given this function, what is the derivative of that function? How do I know when to use the product rule versus when I can just use the power rule? That's a good question. So product rule happens when I take the product of two different functions like I have here. Power rule is when I have a function raised to another power. No problem, Grace. It's like cut off on my screen. What's after the x squared? Yeah, like I said, I agree, Fields and Physics. I'm sure you still remember a lot of things. For me, so when I left college, I taught for a few years, and then I left the classroom, but I didn't do a lot of these problems, so I forgot about them. It took me a couple years to bring this back. Yeah, no problem, Grace. Yes, thank you for letting me know. If that happens, yeah, if that happens where you can't see part of the problem, please let me know. I'm happy to adjust. So here, I have a function times a function. I agree with you, Fields. The hardest part of calculus is the algebra. You're right. That's why in order to succeed in calculus, you really should have your algebra skills down. Best way to review for Calculus 2 next semester. It's been a few years since I've taken Calculus 1. Okay, so one thing that I recommend is to go back, if you still have your notes, go back through them and try practice problems. If not, there are a lot of good resources to help you review Calculus 1. One of them is here. Absolutely. So, here, what I'm going to do is I have a function times a function. So what I'm going to do is I'm going to temporarily split these two functions up. I'm not going to actually split them up within the function. Instead, I'm going to give them different names. So let's call x squared, let's call it g of x. We'll let that be x squared. And cotangent, let's call that h of x. So now, I'm going to take the derivative of each function individually. What's the derivative of x squared? Thank you, Johan, for the follow. Bra says 2x. Jerry's says 2x. Yeah. So the derivative, remember here I'm going to use power rule. Take the 2, move it out front, and subtract 1 from 2. 2 minus 1 is 1, so it would be 2x. Now, what about the derivative of cotangent? Well, let's go ahead and go back here. Of these 6, which of these 6 is the derivative of cotangent? Brand says negative cosecant squared. Jolie says 1 over cotangent. MP says negative cosecant squared. So if I were to take 1 over cotangent, that would just bring me back to tangent. Right. So the derivative, cotangent, is negative cosecant. Very good, everyone. I'm going to write that here. Negative cosecant squared x. And now I have everything I need to plug into my product rule formula. What's the product rule? Well, remember the product rule says that if I have two functions being multiplied by each other, I take the derivative of the first function and multiply it by the second, and then I switch it around by taking the derivative of the second, multiply it by the first function, and then adding them together. So that's a bit of a mouthful, so let me show you what I mean. I'm going to link these two together, and I'm going to link those two together. And remember, in addition, order doesn't matter. So what I'm going to do is I'm going to do the inside first and then the outside pair. So I have the inside pair is 2x times cotangent x plus, well, I have a negative here and a positive there, so that's going to be minus x squared times cosecant squared x. So what I'm going to do is I'm actually going to go ahead and stop here. That is where I'm going to stop. What questions do we have so far? Thank you, Zachary, for the follow. Thank you, Deb Owens, for the follow. And thank you, Physics, for sharing the live. Wow, am I yelling at this mic? I apologize. I just see the bar going up. So, yeah, I apologize for that. I'll go ahead and mute that phone. Thank you, WRY, for the follow. Do you ever do application problems here? Yep. So right now we're just going over the basics of derivatives, but soon we're going to do problems involving related rates, optimization, velocity and acceleration are pretty cool. So yeah, we'll be doing some application problems. I just want to make sure we got the basic derivative rules down first. Thank you, Brian, for the follow. And thank you, Paco, for the follow. So let's go ahead and try another one. Let's try another one like that. Ooh. What grade is this? This is calculus. So, yeah, I'm in college calc. I'll be waiting for tutorials. Perfect. Are you in calculus 1 or calculus 2, Brian? Calculus 1. Okay. So this is right where you're going to be. Oh, thank you for the heart me fields in physics. Just reviewing functions currently. Cool. That's really cool. All right. So now I'm going to put both of these in parentheses to make it to symbolize that we're taking the sine of x and then the tangent of x. Right. You're absolutely right, MP. So first, again, what I'm going to do is I'm going to go ahead and I'm going to name these. So I have this function times this function. So I'm going to split it up temporarily. So thank you, Nadia, for the follow. You're taking pre-calc right now? Cool. That's really cool, Paco. How's it going? H prime of x. So, what should I call g of x? Should I call it sine of x or tangent of x? Is this product rule? It is indeed. It is indeed, but we're doing it with trig functions. Good question, Kenneth. Let's do sine. Works for me. So sine will be g, and tangent will be h. Do you have a Discord I can join? I don't right now, but that's not a bad idea. I'll have to develop one. So, if g of x is sine of x, what is the derivative of sine? And if it says cosine, right, it's cosine. So, almost, Jolie, it's not negative because it doesn't begin with a c. Sine doesn't begin with a c, So it shares the sign. It shares the same sign as the derivative. If it were negative, if it were negative sign, then you'd be right, Julie. Cosine derivative is negative sign, right? So what about the derivative of tangent? Oh, this is not g to the negative first of x. Or g to the negative 1 of x is considered an inverse. This is g prime of x, which tells me derivative. Johan says secant squared. Field says secant squared with a question mark. Yeah, that's exactly right. So the derivative is secant squared x. And now I have everything I need to plug into the product rule. So just like before, I'm going to link outer two together, the outer pair together, and I'm going to link the inner pair together. So what I'm going to do is I'm going to start with the inner pair and then go to the outer pair and add them together. So I have cosine times tangent. So when I say link the pairs, I mean multiplying them together. Or in this case, I mean multiplying them together. So I have cosine tan and x plus sine times secant squared. So sine x secant squared x. So normally I would stop here. However, I can simplify this. How can I simplify it? Well, tangent, remember that tangent of x is equal to sine of x over cosine x. So when I have cosine of x times the tangent of x, it's the same as cosine of x times sine x over cosine x. And since I'm multiplying here, what I can do is I can say bye to my cosines. And what I'm left with is simply sine. And yes, MP. So also secant, remember secant of x is equal to 1 over cosine x. So if I have sine times secant squared, sine x times secant squared of x, it's the same as sine of x times 1 over cosine squared x. And what I can do is I'm going to go ahead and take one of these cosines and move it towards to that sign. So I have sine of x over cosine x times 1 over cosine x. But as we discovered, 1 over cosine is secant, and sine over cosine is tangent. So this would be equal to sine x plus tangent x times secant x. And I didn't give myself enough room to write the answer. But yeah, that is it. Thank you, Fern, for the follow. Can I do a division problem? Yes, I will do a couple division. I just want to we're gonna do one more of these just to make sure we're all set, and then we will move into quotient rule stuff. I'm literally learning this right now. Thank you. No problem, Mari. Happy to help. I guess it was perfect timing. So now, this is dope, bro. I'm on this right now in Calc. Awesome, Alf. Perfect timing. Perfect timing. So before I turn, because I don't have enough room on this paper to continue, I'm going to go ahead and turn the page. But before I do that, I'm going to go ahead and copy down all 6 of these trig rules so that way we have access to them. So, ddx sine x is equal to cosine x. And remember, ddx is just simply take the derivative of this function. Takes me back to my calculus days. Woo, I don't miss that. Okay. So, ddx of cosine is negative sine. And again, I'm just writing these down so that way we have access to them when I turn the page, because it's going to be a lot easier for me to refer to a note card versus have to flip the page back and forth. Plus, I don't think any of you want to see me flip the page over and over again. So this is going to be secant squared ddx of secant is secant tan ddx. And I apologize if I'm missing your comments. Got to go. Have a good night. No problem, Brian. Have a good night. Or should I say good morning, because over here on the East Coast it is Friday morning. Cosecant x is equal to negative cosecant x cotan x. Finally, the derivative of cotangent is negative cosecant squared x. Honestly, it's cool to see how much is locked away in my brain. Thanks for sharing. You're welcome. Yeah, it is really interesting, right? Because especially when it starts to all come back and be like, "Oh, I remember doing this." Yeah, exactly. There's a lot of applications of calculus. Um, some of which aren't obvious. So now that I've recorded all of these, we'll save that, and let's go ahead and turn the page. I'm failing calculus AP. I'm sorry to hear that, Daniel. Um, I'm really sorry to hear that. Um, what questions do you? Is there any questions about any topic that you have or involving this, or is it something else? Physics is literally nothing but calculus. It's beautiful. Absolutely. Thank you, Distracto, for the follow. So, let's see. Let's do this one next. negative sine x, or actually, let's add a times 3 cosine x. Indeed, MP. That is the PSA of the night. What are you working on? So tonight we're working on trig. We're focusing in on the trig derivatives. Good question, Miguel. Yes, please. Please don't consume alcohol while doing calculus. It's not safe to drink and derive. That's right. Thank you, 347, for the follow. So here, go ahead and give this one a try. I know you all can do it. Find the derivative. Oh wow, that was pretty fast, Grant. But remember, it's more than just. Remember, that's a multiplication sign, not an addition or subtraction, so be careful. Do you do discrete math? It's been a little while. I haven't done it. I've used to do discrete math. I haven't done it in a little while, but I could probably relearn it. It would take me a little while. Thank you, Ellipse, for sharing the live. Thank you, Santos, for the follow. You have to take it for your major? Okay. Interesting. What's your major? Thank you for the 5-year awesome fields. Cybersecurity, analytics, and operations. Interesting. What's the highest level of math I do here? I just started going live a couple months ago. So far I've only done Calc 1, but eventually I want to start getting to different Calc 2 and Calc 3, and then differential equations. Linear algebra is going to be kind of cool when I do it. Thank you, JC, for the follow. This looks like Calc 2. Nope, this is Calc 1. It's just Calculus 1. Well, hey, you know what, Trey? You pass, and that's the most important thing. Jake says negative cosine x times 3 cosine x plus sine squared. Sine x squared. Okay, let's see. Let's see if you're right. So, here, I'm going to go ahead and name. I'm going to go ahead and temporarily split this up into two different functions. So I'm going to call my negative sine of x g of x. And I'm going to call my h of x 3 cosine x. So what's the derivative of negative sine x? Field says negative cosine. MP says negative cosine. Josh says negative cosine. Yeah, that's right. So remember, derivative of sine is cosine, but when I have a negative, the negative follows along. So it's negative cosine x. Cool. Now what's the derivative of 3 times cosine x? What is the derivative of 3 cosine x? Josh says negative 3 sine. Field says negative 3 sine. Thank you, Corn Jugs, for the follow. Biggie says 3 sine. Almost Biggie, but remember, because this begins with a C, it's going to be negative. So it's not positive, it's negative 3 sine. Almost, Jake, because remember, that 3 is being multiplied to cosine, so a 3 follows along. So it's going to be negative 3 sine of x. Is this Calc 2? Nope, this is Calc 1. I'm a senior in college, LMAO, haven't done this in 3 years. Hey, that's fair. There are people who have done this in a lot longer, but the fact that you're here tonight tells me that you're interested in remembering this, which is cool. Thank you, Rabbit, for the follow, or at the very least that you're curious about calculus. So hey, why not? So here's what I'm going to do. Now I have everything I need to take my product rule. So I'm going to link those two together, and I'm going to link those two together. I'm currently in Calc 2 after taking 2 years off of college. Okay, that's fair, Corn Jugs. Thank you, Trig Derivatives, for the follow. So now, what I'm going to do is I'm going to multiply my inside functions together. So that's going to be negative times positive is going to be negative. So that's going to be negative 3. Cosine times cosine, well, that's just cosine squared. And then I'm going to add negative sine x times negative 3 sine x. So that's going to be negative times negative is positive. That's going to be 3. And then sine times sine is sine squared. I am, haha, just funny to me how far I've come since then. Yeah, definitely. Why does it change the sign? Are you talking about from here to here, Fabian? Thank you, Cod Rob, for the follow. Yeah, so here, if the original function is 3 times cosine of x, then h prime of x, which means the derivative of h of x, is just negative 3 times sine, according to this rule right here. So what I can do from here is I'll go ahead and factor out a 3. This would be sine squared minus cosine squared. Now I know that if sine squared plus cosine squared is 1. I forget if there's a rule about sine squared minus cosine. Minus cosine squared. I don't think there is. You're right, MP. You're absolutely right. So there's a rule that says that sine squared x minus cosine squared x is equal to cosine of 2x. It's a double angle theorem. Oh wait, no, it would be the other way. But so it would be it's cosine minus sine. But if I factor out a -3, I still get that. So this would be -3 times cosine of 2x. So then you just do a chain rule after? Nope. You're done. Thank you for reminding me of that double angle theorem. Nope, the answer is -3 times cosine 2x. So this is a trig identity. So all I had to do was once I had this trig identity, I could just plug it in here, and it's a simplification. Cool. Yeah, no problem. No problem, Trey. I have I have no problem. Um, I've no. Don't ever be afraid of asking questions in here. I'm happy to answer them. Can't you just plug in 1 minus cosine squared? I could. I could do that. Sorry, I think my live was lagging. Can I send my? Yeah, absolutely. I did. I actually. I'm not sure I actually received your question. Why one? So does this come after you do exponential functions and polynomial and rational functions? Um, because you don't think you've learned this yet. Okay, yeah. So, remind me. I think you said it earlier in the chat, or maybe not. Are you currently taking calculus, Fabian? Okay, yeah. So this is one of the early derivative rules that you learn. So you have so you learn power rule. You learn about limits, then you get to power rule, then you get to um, product and quotient rule. Then you get here. Now I'm not actually using a formal curriculum or anything, so I'm jumping around a little bit based on what I think makes sense. Your math teacher made a L'Hopital joke on the first day. Interesting. What was the joke, if you remember it? So let's go ahead, move on to our next one. This time, we're going to do a couple of quotient rule problems. It showed L'Hopital rule with a picture of a hospital bed. Interesting. Very interesting. I'll have to look that one. I'll have to look up that joke. So let's do a quotient rule problem. So let's say I have sine of x over x squared. So let's go ahead and do this quotient rule. So remember from last night the steps on how to do quotient rule problems. So first step is to identify the top and the bottom functions. So I'm gonna label t of x for top and b of x for bottom. Nope, that's not prime. Here's prime. So here, my top function is going to be this. What's in the numerator? What's in the numerator? Well, that's sine x. And the bottom, what's in the denominator? That is x squared. What goes into t prime? What is t prime of x? Yes. Good one, MP. Very good. That's actually funny. If you practice algebra, you simplify that to sine over x, which don't do that. I agree. Don't do that. Yeah, so the derivative is cosine. And what about the derivative of 2x? Thank you, Sound, for the follow. Solera says 2x. Funniest person of 2025 says 2x. I that's actually that's a good one, MP. Yes. Yes, indeed. So yeah, the derivative is just 2x because of power rule. Move the x out front, subtract 1 from the exponent. So now I have everything I need to do the quotient rule. So I'm going to link those together. And now I'm going to do the quotient rule down here. Why? Because I can. So the answer, remember the derivative is low d high minus high d low all over a square of what's below. So I have low is x squared, d high is cosine, minus high d low. So I'm going to write that as 2x times sine of x all over the bottom squared. So that's going to be x squared all squared. Remember, if I have x to the m raised to the n power, that's the same as x to the m times n. So 2 times 2 gives me 4. Can I simplify this? Technically, I can by just factoring out an x. So if I wanted to, I could write this as x times x cosine x minus 2 sine x all over x to the fourth. And then we can say bye to one of those x's. So I'm left with x times cosine x minus 2 sine x all over x to the third. And that's it. Thank you, B, for the follow. Let's see another. Absolutely. Go ahead and do another problem. So, let's do another example. Thank you, ISF, for the follow. And if I pronounce that correctly, I apologize. I am sorry if I pronounced that incorrectly. I hope I didn't. So, let's say f of x equal to the following. Let's do tan x divided by 1 minus secant x. And I want to find the derivative of this function. So again, what I'm going to do is I'm going to identify my top and bottom function. Thank you, Mr. Too Cool, for the follow. So I have t of x, t prime of x, b of x, and b prime of x. So my t of x, again, is going to be my top function, which is tan. My bottom function is this 1 minus secant. And now that I've identified the top and the bottom functions, let's take the derivative of both of them. Let's start with tangent. What's the derivative of tangent? What's the derivative of tangent? Right, it's secant squared. Secant squared of x. And now, what is the derivative of 1 minus secant x? Thank you, Elliot, for the follow. What is the derivative of 1 minus secant? Not quite. Remember that I think do we agree that we agree that the derivative of a constant is 0, so that goes away. So now all I'm left with is just the derivative of negative secant. If we look here, what's the derivative of secant? I just realized I've been live for an hour and a half and I forgot to drink some water. That's right, Cecilia. It's secant tan. But since there's a negative, the negative joins along. So this is going to be negative secant x tan x. Right, absolutely. Agreed. So now I have everything I need to do the next step, which is to plug it into the quotient rule formula. So I'm going to link my outer two functions together, and I'm going to link my inner two functions together. So what do I get? I hope I gave myself enough space for this. I highly doubt it. But here goes nothing. So this is going to be low d high. So I have secant squared times 1 minus secant minus, well, negative times negative is positive, so that's going to be plus secant x times secant tan times tan. Well, that's secant tan squared. Squared x all over the bottom squared. So that's going to be 1 minus secant x all squared. So I'm going to go ahead and simplify this a little bit. So what can I do? I could factor out a secant squared. What else can I do? Secant squared. Nope, secant x times what I'm multiplying in here. So that's 1 minus secant, 1 minus 1, or, yeah, 1 minus secant x. Nope, that's wrong. Let's try that again. F prime of x. If I factor out a secant out of here, or if I simply distribute that secant squared, I'm left with secant squared x minus secant cubed of x plus secant x tan squared x all over 1 minus secant x all squared. I'm going to continue. I'm going to need some more room to answer that. So I'm going to go ahead. I'm going to take this, write it on a note card, and then copy it to the start of a new page. So f prime x is equal to, I'm going to move it around too. So it's negative secant cubed x plus secant squared x plus secant x tan squared x all over 1 minus secant x all squared. So I'm going to copy that there. I'm just doing this so that I have a little more space. That way you're not trying to decipher my small tiny handwriting. So it says negative secant cubed plus secant squared plus secant tan all over 1 minus secant x all squared. Oh, this is tan squared, not secant. I'm going to try and see what I can do with this. So tangent x is equal to sine over cosine. And secant is equal to 1 over cosine. Does that help at all? So this would just be sine cubed over sine squared over cosine cubed. This would just be 1 over cosine squared. And that would be did I do this wrong? It's possible. It is very much possible I did it wrong. Derivative of tangent is secant squared. That's right. Derivative of this is negative secant tan. That's right. Low d high minus high d low all over the square of what's below. So the derivative is right. Or, so that's right up to here. So from here, what I'm going to do am I drawing a blank? Oh, so if I go back to the original problem. Thank you, Ben, for 30, 40 plus roses. So here, I'm gonna write it out in terms of sine over cosine. So this is gonna be f prime is equal. If I factor out a secant, what am I left with? I'm left with negative secant squared. Or actually, let's factor out a negative. So that's positive minus secant x plus tangent x, tangent squared. That's over 1 minus secant squared, secant x all squared. So that's going to be negative 1 over cosine times secant squared is 1 over cosine squared minus 1 over cosine plus sine squared over cosine squared. All over 1 minus secant x all squared. So I could rewrite that as cosine over cosine squared. Oh! Oh! Okay. Nope, I got it. Negative 1 over cosine. What's going to happen? 1 over cosine squared. Nope, I thought I had it. Minus cosine x over cosine squared x plus sine squared x over cosine squared x. There has to be a simpler way to do this. What if I went back? What if I went back here and tried to simplify that to start? So let's see what happens if I do that. So go back to the original problem. 1 minus secant. So tan is sine over cosine. So this is sine x over cosine x divided by, in order for this, I need a common denominator. So that's cosine over cosine. Cosine x minus 1 over cosine. So if I do this, sine over cosine times cosine over cosine x minus 1. Cosines cancel. We say bye to those. And I have sine x over cosine minus 1. From there, if I do the quotient rule, I get low d high, so that's going to be negative cosine x times cosine x minus 1 minus high d low, so that's going to be plus sine times derivative of cosine is negative sine. And then the derivative of 1 is 0, all over cosine x minus 1 all squared. That's going to be negative cosine squared x minus cosine minus sine x, sine squared x. Here we go. Cosine x minus 1 all squared. Factoring out a negative. Factor out a negative. I'm going to switch the order. Sine squared x plus cosine squared x plus cosine x all over cosine x minus 1 all squared. Sine squared plus cosine squared is 1. So this is negative 1 plus cosine x all over cosine x minus 1 all squared. I don't think there's anything more I can do here, because if I distribute it in at negative 1, I'm not going to be able to cancel, since this would not be, what's inside here, it would not be the same as that. So that's it. What pen do I use? The pen that I use is a Sharpie S Gel 1.0 bold font. But yeah. So I'll explain what happened. So what I did was I used these two rules to turn this into this. Tangent of x is sine over cosine. So I just plugged that in for tan. And then for secant x, I plugged it in as 1 over cosine. So I did 1 minus 1 over cosine. But in order for me to add or subtract fractions, I need a common denominator. So 1 is the same as cosine x divided by cosine x minus 1 over cosine x. And then from there, I just combined these two fractions together. And then once I did this, I divided these two fractions to try and simplify. Cosines go away. I like to simplify and then multiply. So those cosines go away and I'm left with this. From there, I just use quotient rule and simplified. So here, I also used a Pythagorean identity. Which one did I use? I used sine squared plus cosine squared is equal to 1. So that's how I knew that this plus this was 1. So as you can see, even I make mistakes too. And I can promise you that wasn't the last one I'm going to make. So yeah. I don't know about you, but I think it's time for the final problem. So for this, I'll use a new page. If I can get the page to turn. So final problem time. And so, before we start the final problem, there are 20 of us in here. Let's see. Let's see if we can't get to 30,000 likes before the final problem. I know you all can do it. So let's just do a quick mad tap to 30K. Like I said, hopefully everyone's having a good evening or good morning if you're over here like me on the East Coast. Yeah. Oh, by the way, I just checked the I have to after this I have to check and see how Saquon Barkley did. Um, I imagine the Cowboys Eagles game is over. Um, so I have to check the score and see who won. Oh wow, interesting. So yeah, so like I said, tomorrow I'm going to be doing chain rule, and Saturday I'm going to be doing implicit differentiation. And then again, I have to take a look at my notes, see if I'm doing inverse trig first, and then e to the x and natural log, or if I'm going the other way. I know those are going to be the first two terms of the those are going to be the first two things we talk about for live on next week. Thank you, Big Al, for the 69 roses. Oh, I'm sorry, Ben Allison. Sorry about that. For some reason, the chat cut off. I apologize for that. So yeah, we are almost at 30K. I know you're. I know you all got some more taps. And I did. For some reason, when I look at the likes after 10K, I can't see the decimal anymore, which is really weird. I think you all can, so you all know how close you are to 30K, but I don't. You're almost at 30K. Can you all hear me? I think I don't know why, but I think my mic is lagging a little bit. Oh, cool. We just hit 30K on my screen. Awesome. Thank you, everyone, for all the likes. Or does it round up? That would be interesting if it rounds up for me. Because on my screen, I can see 30K, even though I don't know if it says 30K for you all or not. All right, so we have 100 more to go. 30, awesome. Cool, so let's go ahead and do the final problem of the night. So that is going to be f of x is equal to the following. So I have f of x is equal to 1 minus cotangent over 1 plus cotangent. So first, what I'm going to do is I'm going to go ahead and identify my top and bottom function. So I have t of x is 1 minus cotangent and my bottom function is 1 plus cotangent. So, what is the derivative of cotangent? What is the derivative of cotangent? Well, if we look, derivative of cotangent is just negative cosecant. So if a derivative of a constant is 0, so that goes away. And derivative of negative cotangent, well, derivative of cotangent is negative cosecant squared. So derivative of negative cotangent would be positive cosecant squared. And then the derivative is negative cosecant squared x. So now I'm going to link my outer two functions and my inner two functions. So that way I have everything I need to plug it into the quotient rule. So f prime of x is going to be low d high, so that's going to be cosecant squared times 1 plus cotangent minus, well, negative times positive is going to be positive, so this is going to be plus cosecant squared of x times 1 minus cotangent. And that's going to be all over 1 plus cotangent x all squared. So from here, now I'm going to try to simplify if I can. So what I can do is I'm going to go ahead and factor out a cosecant squared. Cosecant squared x. What am I left with? I'm left with 1 plus cotangent plus 1 minus cotangent. That's going to be all over 1 plus cotangent all squared. Now, so now I can combine like terms inside my parentheses. 1 plus 1 gives me 2, and cotangent plus a negative cotangent, well, that's 0, so we can say bye to those cotangents. So I'm left with 2 cosecant squared of x all over 1 plus cotangent x all squared. I don't think I can simplify anymore, so I will go ahead and stop here. And that's it. That is all. So, that is a good question. So there are actually many uses for this. There are uses in physics. There's uses in engineering. If we're trying to figure out sound waves for music, there are a bunch of applications for this. So yeah, we're gonna go ahead and call it a night. But before I go, I do have a couple things that I do want to mention before I end this live. So first is that, like I said earlier, all of my lives are going to be downloaded and posted here. So if you go here, here is my channel, and here is where you're going to find all my lives once I upload them onto here. So if you do these 5 things when you get there, that would be awesome. Also, there are a couple people here on TikTok that I highly recommend you follow. First is ACG Math Tutoring. So if you're taking, if you're getting ready for your ASVAB, your GED, your Accuplacer, your TEAS test, or just need a review of algebra or geometry, I recommend you follow ACG Math Tutoring. She was the one who convinced me to join TikTok here in the first place. So I highly recommend you give her a follow. Also, if you're interested in learning about the abacus, I highly recommend you follow Learning with Lynette. She's actually live right now, so as soon as this is over, I'm going to go ahead and jump in there. And if you want to join me, that is where I will be. And then, I also am an online math tutor. So, with that, here, I had my list here a moment ago. When you have so many note cards, eventually, I need to organize, apparently. But yeah, so I'm an online math tutor. So I offer group tutoring and one-on-one tutoring. So let's start with the group tutoring. So group tutoring is, I offer it to groups of 3 to 10 students who are all taking the same class at the same time. Now that doesn't necessarily mean that it has to be with the same instructor or even at the same school. Here it is. But it has to be the same subject. So for example, let's say that you and 3 of your friends are all taking statistics. Well, if you all are taking statistics, then you can sign up for group tutoring, and for that I charge $35 per hour per person. And then I also offer one-on-one online tutoring for those of you for those who want to go over specific topics or just need help with a specific class. Now, just because a subject isn't here doesn't necessarily mean that I don't tutor it. It just means that I would need to do extra prep to make sure that I would be able to do it. So, if you are interested in either one of those, either group tutoring or one-on-one tutoring, feel free to DM me here on TikTok, and I will set up a free consultation. So with that, I think it is time to call it a night, or for me, morning. So with that, I will see you all. Actually, tomorrow, like I said, we're going to be covering chain rule. Oh, no, yeah, chain rule. So have a great rest of your evening, everyone, and I will see you all tomorrow. Bye, everyone.